Hi everyone, welcome back to my YouTube channel. This is Dr. Ruby, and today we are back with another very interesting theory in educational psychology, developed by two incredible researchers, Raymond Cattell and John Horn. This video is part of our educational psychology series, where we are covering various important topics. I have linked those videos in the description below, and you can also check them out on the playlist called Educational Psychology. We are also posting daily MCQs on educational psychology, which you can find in the short section. Today, we will dive into Cattell and Horn's theory of intelligence and explore how they identified two distinct yet complementary types of intelligence, fluid and crystallized intelligence. And apart from learning about the theory, we will also discuss its educational implications. Why are educational implications so important? Whether you are writing a descriptive answer for exams or preparing for an assistant professor job interview, understanding the practical implications of a theory is very important. When it comes to theories, especially in educational psychology, the professors will always ask you about the implications, how the theory can be applied in real-world educational settings. So stay tuned as we explore both the theory and its important implications for teaching and learning. Now, before we get started, if you are yet to subscribe to this channel, subscribe now and press the bell icon so that you get notified every time I upload a new video. Let us start by learning a bit about the two researchers behind this theory. Raymond Cattell was a British-American psychologist and one of the most influential figures in psychology, particularly in the study of personality and intelligence. He was known for his groundbreaking work in psychometrics, or the science of measuring mental capacities. In the 1940s, Cattell started developing his ideas about intelligence, and in 1963, he introduced his theory of fluid and crystallized intelligence, which changed the way people thought about intellectual abilities. Then, in 1967, his student John Horn expanded on Cattell's ideas. Horn was an American psychologist who worked closely with Cattell and made important contributions to the theory, particularly in the area of aging and how intelligence develops over a lifetime. Together, their work helped establish that intelligence is not just a single fixed trait, but rather made up of different abilities that can change over time. So their key contributions are that Cattell proposed that intelligence has two main components, which are the fluid intelligence and crystallized intelligence. And Horn, he expanded on this theory by studying how this type of intelligence change with age and other factors. In essence, Cattell and Horn help us understand that intelligence is complex, with some parts being more flexible and other parts being more knowledge-based. Now, let us break down the theory that Cattell and Horn introduced in more detail. Fluid intelligence is the ability to solve new problems, reason, and think abstractly. It is like your brain's ability to handle new information and come up with solutions in unfamiliar situations. This type of intelligence is biologically based and independent of what you have learned in the past. It peaks in young adulthood and start to decline as we age. For example, imagine trying to solve a new kind of puzzle that you have never seen before. You don't have prior experience to rely on, so you have to think critically and find patterns to solve it. That's your fluid intelligence in action. Fluid intelligence is like the raw processing power of your brain, the ability to figure things out on the go. This is the reason why younger people are often faster at learning new skills, such as playing a new video game or solving math problems they have never seen before. Crystallized intelligence, on the other hand, refers to the knowledge and skills that you accumulate over time. This comes from learning, experience, and education. Unlike fluid intelligence, crystallized intelligence tends to increase with age as we gain more knowledge and experience over time. For example, think of crystallized intelligence as the ability to remember facts and apply what you already know, like recalling the capital of France or solving a math problem you have learned in class before. If fluid intelligence is the ability to learn new things, crystallized intelligence is what we already know. It is what helps us to use our vocabulary, understand historical events, and solve familiar problems. It is something like assessing a library of knowledge built up over a lifetime. Now, how do they work together? These two types of intelligence complement each other. For example, when you first learn how to drive, you use fluid intelligence to understand the controls, adjust the traffic, and react to new situations on the road. Over time, driving becomes second nature because you have gained experience. At this point, you rely more on crystallized intelligence. In summary, fluid intelligence is your ability to reason and solve new problems. Crystallized intelligence is the knowledge and skills you have learned through life. While fluid intelligence may decline with age, crystallized intelligence grows as we gather more knowledge and experience. Now, let us explore the educational implications of this theory. Point number 1. Tailored teaching strategies. Teachers should recognize that students may have different strengths. Some may excel at tasks requiring fluid intelligence, such as reasoning or solving new problems, while others may perform better when using their crystallized intelligence, like recalling facts or applying prior knowledge. Teachers must include both problem-solving exercises for developing fluid intelligence and repetitive practices for enhancing crystallized intelligence. Point number 2. Balanced curriculum. Education should aim to balance both types of intelligence. To promote fluid intelligence, activities such as puzzles, logical reasoning, and creativity-based tasks can be included in the curriculum. These exercises help students learn how to think critically and solve problems they haven't encountered before. To build the crystallized intelligence, teachers should ensure that there is a strong focus on acquiring knowledge, building vocabulary, and practicing the application of what students have learned. Point number 3. Age-appropriate instruction. Since fluid intelligence tends to peak in young adulthood and decline with age, it is important to focus on developing problem-solving abilities early in life. In contrast, crystallized intelligence continues to grow, so lifelong learning is essential for all age groups. For example, younger students can be encouraged to explore and experiment, while older students and adults can be encouraged to rely more on their acquired information through discussions, case studies, and lectures. Point number 4. Lifelong learning. Crystallized intelligence shows us that learning doesn't stop after formal education ends. As people age, they can still continue to grow intellectually by reading, discussing new ideas, and learning from life experiences. Schools should encourage students to be lifelong learners by fostering curiosity and a love of learning. Point number 5. Assessment and testing. Educational assessment should measure both fluid and crystallized intelligence. For example, Standardized tests can assess crystallized intelligence by asking students to recall facts or apply learned concepts. Meanwhile, problem-solving tests or open-ended tasks can measure fluid intelligence by requiring students to think critically and tackle unfamiliar situations. Finally, point number 6, encouraging interdisciplinary learning. This theory encourages interdisciplinary learning, since fluid intelligence is involved in problem solving and crystallized intelligence draws on knowledge from various domains. Students benefit from engaging with subjects that cut across disciplines. Let's take an example. A student learning about the water cycle in science might also apply mathematical skills to calculate evaporation rates or use creative writing to describe the process. This cross-curricular approach helps students strengthen both types of intelligence, as they can see the connections between different subjects and apply diverse thinking strategies. In practice, interdisciplinary projects such as combining science and history to understand technological advancement can enrich learning and deepen understanding. So that was all on today's class on Cattell's and Horn's theory of fluid and crystallized intelligence. I hope you liked the video and find it helpful. Please let me know in the comment section if you have any questions regarding this theory. Like, subscribe and share. Thank you for watching and see you in the next class.